What's happened to the volcano in Iceland? The volcano in Iceland lately, when I saw it the last time, it had been quiet for a while. Then huge, massive eruptions suddenly. It showed to me that the volcano is very volatile rich. Volatile, by volatile means things like water and CO2 and other gases and steam. And that changed to now the volcano being almost dormant. There's no activity, you don't see anything. Just sometimes a few eruptions in the morning, like this little tiny spot. Similar to this, we have seen as if the volcano is dead. Tens of years has passed, tens of thousands of years. This volcano from Iran, you can see that southwest Iran in Kerman province. You can see that the volcano looks very fresh, like the one in Iceland we have. Even you could see Pauhöjund, some of the part of it. It's beautiful, looks even fresher than what we have in the Iceland. So that Iceland volcano is really evolved very fast. It reminds me personally of what I've seen on the moon. There is Aristarchus plateau in the moon, and that has something we call head of a cobra. It's a volcano, practically, a shield volcano. And it has evolved in a way. And it has a main vent that, as you can see, there's a channel leading the magma and the lava toward the lower in the plane of the moon, those darker area in the moon. It's exactly something like that in this volcano in Iceland. We see this beautiful shot from above. We can see that. Sometimes when there is activity, we can see that the lava is actually flowing under the crust. It looks inactive, but the flow of the lava in this thermal image from the Landsat 8 image in NASA and USGS, you can see that. What is happening is very complicated. I try to explain it in simple terms. Magma chambers are evolving entities. They evolve over time. So when we have a start with a basaltic magma, like the one that we have here, it may evolve over time. The basaltic magma has a lot of crystals, olivine and pyroxene and plagioclase. These crystals are heavier than the normal composition of the magma, so they can settle gradually. And they gather at the bottom of the magma chamber. The top of the magma chamber will be full of more liquid and less crystals in it. And this evolution, liquidy and more volatile rich, is the reason for the highest and volatile eruption. It's like a boiling water having a lot of bubbles. These bubbles are this volatile rich material in the magma, in the top of the magma. They are crystal poor. Crystals are heavier. I told you they gather at the bottom of the magma chamber. On the top there is no much crystals. They form gradually over time. They form what we call as granite or granitoid bodies. And you can see here, you will have eruptions. Suddenly a lot of volatiles released, and they bring a lot of magma to the surface because this bubbling of the magma causes this. Then we have a little period of the quietness. Then this repeats again. And this volcano has evolved so fast. We are seeing this stage of the volatile top of the magma, juicy magma as we call it. Like the one in Iran also, you can see that it has evolved and now it's stopped almost. And juicy magma is the one we see. We actually have seen this less dark, less black magma in Iceland. We saw gray magma. We have reports of gray magma, very light color blue magma in some. And that is the evolution of the magma as we see it in real time.